Alrighty, so today we're moving on with chapter 3i, which it kind of starts a little bit of a different section with chapter 3. So we need to have a quick introduction or refresher of introduction to solving simultaneous equations. So a definition: simultaneous equations are two linear equations that occur simultaneously, which means at the same time. Okay, simultaneously means at the same time. Solving simultaneous equations. To solve, you need to identify the point at which the linear equations cross or intersect, which is what you'll see a lot. So when you have those two lines on a graph, where do they cross? Okay, that's the intersection, and that's the solution to those two lines. There are several ways to solve simultaneous equations. So hopefully you remember when we did matrices in chapter 5, going down here, this is a bit of a recall, okay, we did this for matrices. So you had two equations, okay, you could put them into matrix form, and then you could solve it using the formula, or you could use your CAS to solve it. Okay, so that's a bit of a recall, but we're going to look at the other methods of solving simultaneous equations, algebraically and graphically. Okay, so that's what these other methods of solving them, so graphically, which is what we're looking at today for 3i, but there's also the algebraic way as well. And obviously there's always a way to use our calculator. Alright, so moving on to 3i. So this chapter is about finding the point of intersection of two linear graphs. So where do they intersect? So like I said before, solving the two equations, you need to find where they intersect. Graphically means that if you graph your two lines, you can find that intersection. So there's not really a whole lot of algebra or maths. It's literally just graphing, and then you can see. You should be able to see the intersection. So the point at which two lines cross or intersect is the solution. And to provide the solution, you have to give the coordinates, which is that x, y in the brackets. So for example, we've got two lines here, line 1 and line 2. Okay, so they've been graphed, they've been put on a Cartesian plane, and the solution is where they cross. So from looking at that, okay, so from put on the graph, they cross over at negative 1 there is a negative 1, 3. So that's the solution, okay? So like it says here. So all it is graphing your two lines and finding where they intersect and then giving the solution, so the coordinate of where they cross. Using a CAS, so there are instructions here of how to add a graph, okay, is step 1. So you need to actually open a new page and click on graph. You type in the equation, so it's like in this little section here, and then you hit enter and it should sketch the line. Obviously we want to put at like two lines on there, okay, so don't press enter on the first one, hit the down arrow first, put in the second equation, and then you hit enter. Okay, so that you get, like this example over here, you should get two lines. Now we want to know the solution, so the point of intersection here. So to do that on your calculator, you need to go to Menu, Analyze Graph, Intersection. Then your mouse will appear and you have to click and like scroll over. So you just kind of make sure when you click it's on one side of the lines, and then move your mouse over to the other side. Okay, so that it'll find the intersection in between that, like you're putting in a bit of a boundary. So when you do that, so over on this example, it comes up with the intersection here, which you can see in the little brackets, it's negative 1, 3. Okay, so that's how you can do it graphically on your calculator. and settings. So just in case it's not working out for you, if your graph entry is missing, to bring it back up, you can follow these instructions. If your equation is not in y equals form, so usually we're used to y equals mx plus c, and you should be able to graph using that. But if it's not in that form, what you can do, so that means the x and y variables are on the same side. What you can do is when you go to enter a new graph entry, okay, so similar to step 1, instead of clicking function, you want to click equation, okay, and then line standard. So it kind of, it'll turn it into the general form so that it can be easily identified. If your intersection is not visible on the screen, okay, so that means you've just got to move your graph to find that intersection. What you can do is go to menu, window, zoom, go to your window settings and put in a max or minimum. So if you're not seeing an intersection, you could change the Y. So if you've got your axes here, okay, you might need to change your Y to an upper bound of like 100 so that it stretches out more, because your intersection could be up here. Okay, so that's always good. I also like to use the zoom fit, so you could try using that. So any one of these will kind of work, so it's up to you. If you have the Casio class pad, there's some instructions there for you. And that's it. You can now complete exercise 3i in your textbooks.